Not all ships are the same, so why are most fenders? For decades, protecting a ship meant a one-size-fits-all process filled with toxic chemicals and costly downtime. But one company is printing a better way. 500 kilograms of TPU a month, 9 machines running non-stop. These aren't just production numbers. They represent a fundamental shift. A shift from a toxic, decades-old process to a customizable, scalable, and ecological one. Now, NewsFender is breaking the mold, literally. And we go inside their factory to see how Bigrep technology makes it all possible.
Hello, my name is Fernando Fortunato. I'm the CTO of NewsFender. In NewsFender, we do fenders for ships, fenders for rescue ships, for firemen ships, and we also do for docks and from ports. We are manufacturing and developing materials for seats and cushions, for example, the one that I'm holding now. We also going to 3D print a full ship. We are going to 3D print the console, the full hull of the ship, some parts of the gasoline tank, seats, cushions.
This is a dock fender. It's made from TPU and is now used in many ports across Spain. It's meant to absorb the impact where a ship's hull meets the dock, rather than relying on fixed sections. Because it's 3D printed and customizable, the engineers can simulate and predict how to reinforce it for the anticipated loads.
So here you can see how it's inside, how it works, the mechanism. It's not so easy to squeeze, but... So here in NewsFender, we develop a new way of building fenders. The normal and traditional fenders, the bumpers, so to say, or defense of the bolts and the ports, they are really toxic to the environment and for the workers. For example, they are all painted and coated with polyurea. For people who are applying the polyurea, which is sprayed, this polyurea is really, really toxic. So we are changing the paradigm, the way of doing things with NewsFender. So we are trying to adapt new technologies to an existing market, which didn't develop much in technology. For example, they have pictures in black and white with the same fenders that you see today. Since 60 years, it's the same. So we have a really big opportunity here to make an impact, change the way of doing, change the way of thinking to designing. So from now on, we are trying to do things different. So this is a ship that we did in Sweden with Victum Boats, which is a really great customer. This is one of the pieces. So everything again is modular, just add some doubles here and the connection is easy to go. So we choose 3D print for many reasons. One of them is with the 3D printed we can customize. So if a customer wants to change the shape or go crazy and design and shapes and forms and performance, we can just customize everything. We can change colors, we can do glow, we can change the harness. I can put 2 or 3 levels of harness inside of the fender. So we are working with the police and the Guardia Civil, and they love it because they mostly ram against another ship. So the fenders goes damaged, deform, and there is no way to get it back, so you have to replace the full thing. It mostly breaks always in the same parts, the fenders. So I make it more strong in that place, I make it more soft in the other way. I know what the people are going to use it. How can we go in eco materials that is a good solution for the fenders problems? And we discovered polyurethane TPU is one of the best things that we've found. We are testing with carbon fiber TPU. We are testing foam TPU that you can change the harness, depends on where to use for cushions. This is glow in the dark TPU, which as far as I know is the first one in the world. We are doing our own blend of this because our glow TPU shines 8 hours. So the normal ones is 20 minutes to 1 hour. Our ones are shining 8 hours long.
In their R&D department, they turn modular concepts into practical fenders. These pieces are for a 15-meter rescue vessel, printed in segments for prototyping, and then assembled to check fit, weight, and performance. Engineers begin with digital models to predict how the parts will handle roughly 40-ton impacts, and simulations show where stresses occur. They tweak infill patterns and wall thicknesses until everything is ready for a full build.
So what we're trying to do here is more like a system of connections, like a puzzle. So these two pieces fit together, and for example, you will see here, we have always male and female connections, and they hold each other with a screw here on the ship. So here we are testing all these solutions about how to fit all them together so that we have a structural way of building. So for the moment we have 9 machines running. They're around 24 hours since we start. For the moment we are doing, when we are in full production, 500 kilos a month. We are probably going to ramp out now to 700 kilos a month at least. You can rely on the machine. I have machines there too from 2017. The other ones, 2019, 2020. About hardware, you're really good and safe. It's really low maintenance. So having a good material that you can rely on, having a good hardware, and having a good engineer who's well-trained and know about 3D printing design, that's the main ecosystem that you want to have. Here in our ecosystem, we're using Connect to send all the files back and forth to see how is the state, if it's printing, how it's going, and check on the cameras. And we're also using Blade for the everyday life. So we are using here the Bio machine, the newest from Bigrep. It's so easy to use. You have a dry box, you have a filament change automatically. So everything is just so easy to set up. Also, one of the big advantages is that we have the tungsten nozzle here, which we use it because we are printing glow-in-the-dark materials, which is quite abrasive for a normal nozzle, so I have to use only this machine for that. So you have a multi-material machines doing every shape that you want. You're just limited by the size, which in Bigrep is not a fact, it's not a problem. It doesn't restrict me on size, actually.
With 9 Bigrep machines running around the clock, NewsFender produces custom solutions with improved performance and without all the toxic materials, transforming fender production into a streamlined, low-waste process. Ports across Spain, and now beyond, are adopting these 3D printed fenders, and custom versions are also being fitted to a variety of vessels, showing that innovation can come from rethinking the smallest details. When every ship is different, every solution should be too. And with designs that let engineers tweak shape, shell, or firmness, the future of marine protection isn't just floating in harbors. It's being printed, one layer at a time.